Hi, my name is Gary Taylor. In this video, I want to talk a little bit about mass transit producers. Um, this video is a learning tutorial. It's just a bit of a walkthrough where we're having fun going through the documentation, trying to learn a little bit more about mass transit and getting to grips with it. Now, mass transit is quite large under the hood. There's lots of features and lots of policies in place that are helping you. And what I want to do is to start digging into it. I know how to use it. I know how to create a producer and a consumer, but I want us to go further and to start learning what exactly is it that's going on. So first, what is a producer? Well, I highly recommend you go and watch my previous starting videos that explains what a messaging system is, and that kind of explains what a producer is. But for the basis of this video, a producer is something that is asking for someone to do something. Within C Sharp, you might think that as raising an event or a button click or a user hitting a API endpoint and something happening. Something is being produced. Someone is asking for some work to be done. And a producer can send a message to a queue or an exchange directly. Here's some work. Hold it here for me, please. I don't care what you do with it. Or it can publish it using its message type. So whether it be its concrete type or its interfaced type, and then that can be consumed into multiple queues or multiple consumers. And it's relatively simple. Once you have the boilerplate code for connecting to the queue configured, which you'll obviously use dependency injection for, of course, then in that case, you're talking maybe a couple of lines of code to actually get a message onto the bus, which is really, really cool. So if we head over to the documentation here, we can see on mass transit that we start talking about the two different methods of being able to submit an application, or submit a message rather, and that would be the send or publish. And it just explains that the behavior is different. So when a message is sent, it's delivered to a specific endpoint using a destination address. But what does that actually mean? What's an endpoint? What's a destination? What do you mean by delivery? When a message is published, it's not sent to a specific endpoint, but instead broadcasted to any consumers which have subscribed to a message type. Um, Once again, what does that actually mean? What we're publishing, what we're talking about endpoints, what is a broadcast, and what is a subscribed. And I find that as I go through this documentation, the things I'm learning here make the things at the top more understandable. I find it very similar to learning Redux, where I only really got it once I got to the end. Once I'd learned all of the inner workings of Redux and all of the different parts, then I understood Redux as its whole, and only then did it actually, the light bulb appear. And I'm having that with mass transit. I'm getting through this documentation and I'm going, right, so that is a difference. We've already been using producers and consumers in all of these previous examples. But we're talking about destination address and endpoints. I believe we're talking about the actual queue that it's going to arrive at, and we can specify what queue we want it to go to when we use a send. But if we use publish, then we're really just shouting out into the ether. It's a bit like going to your employees and shouting, "Can somebody please do this for me?" and walking away. And at that point, you're hoping that one or two of them people are going to start doing that work for you. And that's what you're doing by broadcasting. And your consumers are basically everyone that was listening at that point in time. If some of your employees had the headset off and were actively engaged in listening, then they'd be subscribed to you. They would be listening to you. Maybe you're the line manager and therefore they took a notice, and another bunch of people have got a different line manager, so they weren't subscribed to you talking. That is the same thing here. And here we can have multiple consumers all ready to take that particular value when we publish it. So that's quite interesting. I like that that terminology. But I did that little graphic to try and illustrate that point. So here we can see when I send, I can choose to go to a specific queue. I can say the queue name. I can specify whether it's temporary, or whether it is a durable queue, and lots of other lovely configurations I can do at the point. And if I just don't care about the queue, if it's none of my business as a producer, I can just say, can somebody please do this? Can someone please process this order? That goes onto the exchange using a contract, which we've seen before, but just for now, a contract is an interface type of that message. So if your message that you have pushed to the queue is an I submit order with all of the appropriate properties, enough with enough information to actually process an order, then it'll go to the queue or queues and then get consumed by the appropriate consumers, which will do the work of actually processing that order that's been submitted. Now, as we go into it, there are talks about using send and publish as delegates and events, or an event or a task. For instance, send would be submit order, and publish would be order submitted or completed or processed. And that's the way it's been talked about within the documentation so far. However, when I start looking at this way of looking at the difference between send and publish, I feel it's just down to how we want to use contracts, how we want to use the queues, how we want to use the destination address, which at the end of the day is the queues directly. Now, the interesting part is you can use send to just go directly to a queue, where with publish, you'll generally go through an exchange which will delegate that responsibility off through to a queue. On the face value of that, then, it means that send is it feels more secure because you're always going to have a queue. And if you have it durable, which is by default, I believe, and if you have it as non-temporary, or the default, which is not to be temporary, you've got a really strong process there of not losing any messages that you want to put in flight. So before we start talking and looking at the send section, I'm actually going to build a prototype. Now, I'm not going to show you the video of that. I'm just going to get straight into it. Um, And then I think the remainder of this will make a little bit more sense. At the moment, this feels like gobbledygook. You know, send a message to destination address delivered to the message endpoint, such as a queue. Send message overloads the iSend interface of called, which is then sent to the transport. It doesn't really make much sense to me. This guy's an absolute genius. I am not. I need something to be watered down a little bit for me. So I'm just going to go into Visual Studio Code. Obviously, you can use whatever you want. And I'm just going to create a new Mass Transit Send project. So I'm just going to dive into that. And I'm going to install Mass Transit and obviously RabbitMQ as packages. Now, I always use the same type. I always specify the version number, even if the version number is the latest, because there's no guarantee that you're going to have that. And let's say you're on version 8 when you're watching this video and this tutorial doesn't work. That's really annoying. So I always provide the version numbers just to make things easier. We're going to be connecting to RabbitMQ, so I'm going to want that. Okay, and I have an event contract project that has some interfaces. I'm going to include that in this project. These are just interfaces. This project is shared across all of my sample projects. So there is a common project which holds all the interface types. Now, of course, that is tightly managed by Git and by workflow and by pull requests. So the interfaces are for life, not for Christmas. But obviously during these playground areas, this is just my code, so it's safe. And finally, let's put in dependency injection, because I like that goodness, although technically don't need it for this simple app. Let's go into it. Oh, I'm already in. I'm just heading back to the website to see what we are going to do with this. We're talking about just using the send. He's warning us about making sure we use the same type, but I'll go into that in more detail. Send, what we're going to do. So we're going to get an endpoint. We're going to use a service address endpoint variable. We're going to submit that and send it. So service address, is that anywhere here? No, it's not. Great. So you can't really use this because it's not finished. We just got this service address variable. I don't even know if that's a string. It probably is. So I've watched the video as well, so I kind of get an idea of what's going on here. So I'm going to see if I can produce this and replicate this in my code. So as I was going over this, I was trying to make a producer that can use this block of code. And of course, you can't because we haven't got a variable for service address. We have no way of knowing how to call send order or even providing this concrete type, which is of type I send endpoint provider, or even what I send point provider is. So I had a bit of fun with this. I had to go away and do some research and play about with it. And I'm still not sure how this code would ever work. And my only guess is that it's some kind of dependency injection in a MVC app or something. So I wanted to do this in a console app. So if I flick over to my console app, please forgive the boilerplate code. We are creating the bus. Just a cancellation token if I can't connect. We're starting the bus up and I'm going to get some input from my user console. Once I've done that, I've got that input. This is where the magic is happening. So at this point, what I'm doing is I am actually using my bus that I've just connected and configured. And I'm going to AO8 and get an endpoint. And the endpoint that I'm interested in is an endpoint for a queue called service address. And that's what I'm going to call it. Then what I'm able to do is send a message out. Now I have a submit order interface already that is an order ID, so slightly different than the implementation here, which is looks like a string value. We're also creating a concrete instance of a type. However, generally we don't have concrete instances of types. Generally we'll use interface types and use something like duck types to transpose or translate that um, dynamic object into that type. I like that way of doing it. So I've done it here because I don't want to create an instance of submit order. I don't even want a class for it. So I am here going to my bus. Now within the bus I have access to a get send endpoint, which means this get send endpoint, which would be this send endpoint provider, which will be somehow passed into this method. I'm actually just getting it directly from my bus and I can create a new. And as I was doing this, I figured out that service address is actually a URI. So it's a URI that qualifies whether it's an exchange or whether it's a queue, and I can provide the name. So when I send this now, I can submit an order, and as long as I'm using this send endpoint, I can choose where to send this message to, even if I've used types. So if I head back to my diagram, we were saying that if I use types for publish, I can use a really nice interface type like that. And I love that. And it will then go to the appropriate exchange and then fan out to the appropriate queues or topics or whatever technology you're using. Basically, let me say that again. When I use this submit order, the publish will go to the exchange and then it will be binded to the appropriate queues and therefore binded to the appropriate consumers. However, I do like it within the send, even though I'm going to explicitly say what queue I'm going to use. So I get the best of both worlds here. Now, if I wanted to, I could now use this same type to send to different endpoints, which I'm going to call queues. So if I was to do that, I should end up with two queues. Now let's run this. Let's provide some data. Ah, of course, idiot. Let's scope them variables out. One, two, three, four. Let's go over to Rabbit and see what we've got. So we've got an exchange now called service address and another exchange called service address XXX. And we should have the appropriate queues as well. And if I have a look, I already had some messages in the other queue. But if I go into here, I should see the messages with the user ID. Now notice I don't have that 1, 2, 3, 4. That's just because my interface is slightly different. I didn't bother updating it. I prefer GUIDs rather than IDs. So here we can see we are creating the exchange, we're creating the bindings, and we're basically doing a one-to-one to the queue. If I look at the bindings, I should have a queue. Yep, that's that service address. If I do the same for the XXX, I'll have a binding from the exchange to the queue, and we've got that. So this was really concrete. One of the things I've noticed with publish is it's easy to publish to an exchange, but the queue doesn't get set up. Where when you use this send mechanism, it completes the whole journey, which is far more concrete. So originally my idea was to use publish for everything, where I'm beginning to feel that we should use send for everything. So ideas and opinions change as you learn more. So the interesting thing now is the endpoint address, which we now know this service address is just a URI. So it's just a URL really. And here we've got some examples. We can use an exchange. We can go to different actual Rabbit exchanges, not exchanges rather, sorry. Probably Rabbit instances like RabbitMQ1, RabbitMQ2, RabbitMQ3, wherever you've got them hosted. You can provide values to configure them. So if you want them to be temporary or if you want them to be durable, all of the configurations that you would have within a queue, you'll be able to specify as you construct it, which is pretty good, which means that you can have these as variables and you can configure how you want your queues to act, and you can configure them within custom variables that will then echo out. So this was the mechanism that I used. I just used queue and the queue name. And this is relatively new, which is why I always put my version numbers when I'm showing examples. As we saw, although I'm using queue, both exchange and the queue will be created if they don't exist. That's really, really strong. That's a really good process because it means that we're not going to break anything. But also it means that we're backwards compatible with other queuing mechanisms. If I was just to use the exchange, it's only RabbitMQ apparently at the moment that's supported by that schema address. Now, whether that's a limitation of the other services, I don't know at the moment. My guess is yes. And because of that, if we use QName, we can migrate to any other queuing systems we want to. If we decide that hosting our own RabbitMQ servers isn't providing us the benefits that we need, we could just go to a managed Azure service bus. Well, it's a simple change, right? Especially if you've got these queues and configuration URLs as variables, which are then managed by config. That would be awesome. So here we go. We're looking at conventions. Mass transit is really big on default conventions, patterns and processes that hold your hand but have the ability for you to extend or override them. And here we're talking about the convention of namings for a particular message. So here we've got submit order, and we should be able to configure how that works within a convention, so a config convention. So it feels to me that we're able to configure the endpoint, which is the service we're going to connect to. Now, because we can provide a URI, that endpoint could actually be one of many things. It could be the exchange, topic, or a queue. In fact, it can be a topic in this convention because apparently it's not supported. So it can be exchange or a queue. And that endpoint then will be used whenever we're using that type. Now, that's my guess. So we can say just bus.send, submit order request, convert to command. No idea what all that's about. So let's just see if we can simplify this, shall we? So I just commented out the previous service endpoint, and I'm just going to use the send directly from my bus. So instead of using a configured endpoint, I'm just going to use the generic one that comes with my bus. And I'm going to submit my order in the same way. But at the top, I'm going to configure it. I'm going to say that we're going to configure the endpoint for this type, and we're going to use this long URL. Now, I'm not quite sure what this will even do. Let's give it a run though. Okay, so we submitted 3. We don't seem to get any errors. So if we go into Rabbit, there we go. We've got an order processing, which doesn't seem to be bound to any queues at all. But if we have a look at the definition, we've just got Rabbit, we've just got this. So I'm not quite sure what all of this does. So that's something for me to research on. But we definitely seem to have got an order processing exchange, but that was it. Now I wonder if I change this to queue, it'll come to life. And I'm just going to change this to queue. Helps if I spell it right. And I'm just going to call this order processing v2. Let's give that a run. What I'm expecting now is for the queue and the exchange and the queue to be set up and the binding to be set up. So we've got the exchange and we've got the queue, and there's a queue alive that's configured. Awesome. That is really cool. So instead of us having to understand that we need to create this service endpoint for all messages of that type, then we can configure the type in a general configuration area, and then everybody else just sends orders, but they don't know that it's actually using a different naming convention or a different endpoint. That is very cool. Now, of course, that's when you're using typed messages. So if you're using interfaces and you're going to send using a typed pattern, if I have a look at the previous example where we're submitting a submit order, I'm not quite sure if it would work with a concrete type. At the moment, I'm using interfaces, but do you know what? I don't actually ever want to find out because I don't want to use them. So if you do, then go ahead and play. For me, I really don't. So I'm not even going to bother learning it. So here we have this send, which is using the standard bus. We're going to send, and we're going to convert to command. No idea what that is. I've searched all the code. I've searched GitHub, searched the internet. Don't know what convert to command is or does. So got to ignore it for now. If we have a look at Endpoint Convention, this is the same that we've just used before, where we're configuring how we want that type to go, what the endpoint or queue or destination is for that particular type. But obviously we should use config. Um, you can use local variable settings. You can use Spring Cloud config. You could, with Steel Toe, you could use Azure app config or secrets. Whatever you use, just make sure you don't stringly type this, make sure that that is configurable somewhere. You really don't want to be releasing code just because you want to change this stuff. It's pointless. You're introducing risk. So get them in as variables and allow you to configure it quickly. So that's what we're using here. It's just, even with this, I believe that app settings is local config. You can either get it from the actual app settings file or it can default to go and get it from event variables. But I think it still needs a restart. So think about something a bit more concrete than that. And then quite randomly, we just seem to have a consumer. Well, luckily we've already talked about consumers, but for the sake of this video, a consumer is the thing that's going to take your message and process it, do something with it. You shout it onto the ether, you go to your employees, you can say, gang, can somebody do this? And one of them will do it. They're your consumer. They are listening to you and they're going to do the work that you've requested, and you can walk away and play your golf. But with this, these consumers are some C# code that subscribed to that queue. They're actively engaged and listening. When a message goes onto the queue, a consumer processes it. So here, this consumer is responsible for dealing with the submit order. It's going to process the order, and then it's going to send another message using a new type, which is start delivery process. So what we're saying here is we're going to process this order and then we're going to deliver the product. So I'm taking it that, here we have to squint a little bit and think about it, but I'm guessing process means it's going to do the payment items, it's going to confirm the address, it's going to take the money out of the bank account once that's gone through, it's then going to deliver it. However, there's a separate system, there's another part of the ecosystem or infrastructure, or even maybe another division of the company that's responsible for delivering. So here we take that logic out of this code, we delegate it, and we say that we want to deliver this order, please. The thing to notice is that we're actually not using the bus. We're actually using the context of this consumer to send the message. And that is really interesting. So beforehand, we saw how to use the bus. We reviewed how to create a unique service end bus, endpoint destination bus that was configured to connect and send messages to a dedicated area. But now we actually have a third way of sending messages, which is to use this context. So as always, I've done a little bit of research on this, and it turns out that when you're trying to debug your application or you're trying to monitor it, you can run into spaghetti code where one producer calls a consumer, that consumer calls another producer, that producer calls another consumer, and so on and so on. And there's nothing stopping that consumer from producing and sending it to that consumer. Nothing at all. You could daisy chain and go as deep as you want. You shouldn't, but you can. So in reality, these things should be separated, decoupled, loosely coupled. The whole idea of queuing mechanisms and this type of ecosystem is so that every single part is separate and standalone, testable, isolated. However, in the real world, things are never that easy. It doesn't matter how hard you try, you are going to have some issues. And it's very nice to be able to see how information flows because this is all one request. Although these can be done at any point, a consumer could wait, it could be offline, and it could process that order, and then that consumer might be offline and it might process that delivery request. It doesn't matter. This is still one request, and this customer has made this one request. So if we know that an order has failed, and sorry, if we know that we weren't able to dispatch a particular product, then surely we should give the customer the money back and we should tell the customer that that's happened. But we might not have that mechanism to do that because we weren't able to bubble that data back up. Well, if we use the context from the consumer to send another message, to produce another message, then information is chained together. That request becomes one request, one action. It gets one unique conversation or correlation ID that allows you to track it. And that makes it really easy when you're looking at your error messages and your logs to actually see what's happened and to replay them events in your debug environment. And there are some amazing tools out there on the internet that allow you to take advantage of that. So one of them is by Datadog. There are many others, but this is application programming management, I think. And it's about being able to trace that data in multiple languages across your ecosystem. So here we can see data moving from a consumer to a producer to another consumer to another producer. We can see the latency, we can view the logs, we can see the error rate, we can drill down into the individual traffic and see whether the consumer was under strain or was generating errors. You can view it in code, so you can see the stack trace working as it moves from system to system. So imagine you've got some code somewhere running in-house. That then connects to Azure, which then connects to an AWS system, which then connects to a Google Cloud system. You can monitor and trace all of that within one platform because um, MassTransit and RabbitMQ have kept that span, that information, and it's linked one request to the other. Even though they're being processed by completely different servers on a completely different cloud architecture, you can still monitor and see that either live or going back to previous logs or forecasting or monitoring. And you can also use that to find bottlenecks. If you are chaining things and you are only going to completely complete the transaction once we know we're able to send it, then you need to be able to bubble these transactions back up and you'll be able to see that data going upwards and down. Now, just a word of warning, don't ever store real data in your logs. Just store IDs and things that can't be identifiable. But these are huge tools. Datadog is very good, but there are others as well that you can use. But if you integrate login and you integrate this tracing ability, you'll be able to see data moving through your stack. And it doesn't matter what stack or architecture that's being run on. So the next bit, it talks about the Endpoint Convention, which we've talked about previously. This is where we're able to configure a single place, and they warn us that we can't do it twice, they said. It says, important to remember that you cannot configure conventions for the same message twice. Now, what I think they mean is, I don't think they mean message. I think they mean message type, I'm guessing. So if I did that, they're saying that we'll get an error. Hmm, no. So I wonder what that actually looks like. Have I sent it to two different places? I have. Okay, okay. Well, that's a surprising turn of events. We can configure a message to be submitted to multiple queues just by configuring them like that, which is actually quite cool because you might want to be able to do two things at once. You might want to be able to send an email, send a text message, send a link to a testimonial when someone completes an order on your website. But that's not what I was expecting. I was actually expecting it to throw an exception. convention for the same message twice. If you try and do this, the map will throw an exception. No, it doesn't. So I remember having this type of problem before with the failed underscore failed queue, where if you have a problem, it'll go into that particular queue. Like if you have a consumer that's not registered correctly, and it ended up if you had a type that wasn't registered to that to that queue. So if you were publishing a type, but there was no consumers that were registered and processing that queue with that type, then they generated a failed message. No, it was a skipped message, sorry. And I couldn't get that to work, and I eventually got that working. He won't be wrong. It will be me because this guy's great at what he does. So I'm not quite sure what he means by this because he's saying that map will throw an exception, but we just saw no, it didn't, and it allowed us to process two exchanges, two queues for that type, which was actually really useful. Consider we want, like I said, consider you want to do two or three things at the same time, but you don't care how. Send an email and a text. Well, you're not going to not send the text because the email failed and vice versa. So you might as well just send them both at the same time. So let's move on to publish. Publish seems unremarkable. It seems very similar to send, but we're saying that there's a key concept change. In the each message published, a copy of the message is delivered to each subscriber. So subscriber, does it mean consumer? Or, subscribers, consumers connect to queues, they subscribe to messages. So are we saying that this now allows us to bubble out a message to multiple consumers simultaneously? Well, if that's the case, we could have done it that way. So, but that's hard work because we have to, if we now need 20 consumers and we want to do 20 separate things at the same time with that message, well, we'd need 20 lines of code for 20 exchanges. Well, yeah, 20 exchanges, 20 queues to manage one message. And then each consumer would have to connect to version 1, 2, 3, 4, 19, and that would be ludicrous. So let's have a look at how we can use send instead, publish instead. And apparently we have the ability then to consume that by multiple consumers. As a side note, what I have started to notice is that all of this is beginning to make a little bit more sense. Because we're using publish, well, publish uses a publish endpoint provider, which then uses an iPublish endpoint, which is then used to send the message to the exchange, to the queue, and they do it in slightly different ways based on send and publish. So when we look at send, for instance, we can see that send is actually a iSend endpoint provider. And if we look at iSend endpoint provider, we can see that the endpoint is an iSend endpoint. And all of that now starts to make a little bit more sense. He's just telling you that there are different conventions between publish and send, and the code implements that convention or mass transit convention for you. Use these classes or use these interfaces, it works this way. Use these methods, use these classes this way, it works in another way. And then it's up to you to use the appropriate one to solve the business problem that you're trying to solve. So all this begins to make a little bit more sense because there is a bus. We can configure that bus. There's an endpoint that we can establish. There's a context which allows us to daisy chain the messages, as we just saw. And then there is a publish endpoint provider, which gives us access to a publish endpoint, which gives us access to the message. So all this now is beginning to make sense. Right at the top, it just didn't make any sense whatsoever. So let's have a look how we're doing this. We are using a published endpoint. and we're going to publish. So this is the same kind of goo that we had last time, in the fact that we don't have a publish endpoint because we can't call this method. So we can't call that because we don't have an endpoint. So, and then this is just a random consumer that's consuming that message, but this is all within a publisher. So none of that really works. So let's try and turn this into a real boy. Okay, so I've cleared down the exchange, I've cleared down the queue. I've commented out these other ways of sending, and I am going to use just standard publish. Now I'm going to keep the endpoint convention set up so that submit order is going to use this queue, and I'll show you the two different ways. I don't even know if this will work, by the way, so let's give this a go. I'm guessing we'll just use a publish, and we will get a exchange and a queue. So let's see what happens. Right, so we have just used the naming convention of the contract. So the interface itself is called event contract namespace submit order. Event contracts semicolon submit order namespace interface type. And the interface is called submit order, not I submit order. It's a MassTransit type idea, a Java thing as well, because we don't really want concrete implementations of this. So we don't actually need I submit order, but it's up to you. So it appears that configuring the endpoint convention doesn't work for publish. So if we use a iPublish, actually that should be, I expected that to be an iPublish endpoint provider. So it's not, that is just a publish message. If I look at send, send uses, yeah. So publish uses just not a value. There's loads of extension methods to overrides to this. Message, message, message. And send uses I send provider. Sending is an override method to the I send provider. And then publish is just a method on it. It's not an override, or an extension method rather. So we can see publish seems to be a lot simpler in its implementation, which probably means that this stuff doesn't work. Or what I mean by that is it's configured in a different way. Of course, with publish, you can still specify what the endpoint is, but you configure it in a different way. So here we will publish an order submitted, and we just got an example of a consumer which is taking that message in. So all that seems simple enough. One thing I wanted to test was that, so the key concept of this is for each message published, a copy of the message delivered to each subscriber. The mechanics by which this happens is implemented by a message transport, but semantically the operation is the same. Semantically, rather, the operation is the same regardless of which transport. So it's saying that, or I feel it's saying that we can publish a message and it's delivered to each subscriber. Now, let's have a look at that, shall we? So here I've got the same publish code. Forgive me, I know it says MT10, but obviously I changed the same code. And I've got 3 consumers reading these messages. So if I go like 7, we can see that it hit this consumer, but not the others. So let's keep doing that. 8, 9, 10. In fact, I'm not even going to count because it doesn't matter. I'm just going to keep on going 1, You see how each message is being round robin? It goes to one, then the next, then to the next, and it just keeps doing it. That same message ID, that unique GUID, isn't being processed by each consumer at the same time. It's being round robined to each consumer. Now that might be a configuration because you can configure fan outs, you configure topics, you can configure the way that that's submitted. And to me, that's probably the default convention. But that's not how I read it when I look at this. I read this as the message will be sent to each subscriber. And my current feeling is that a subscriber is a consumer because a subscriber is the um, thing that's connecting to the queue and saying do something with it. Um, so once again, I'm misunderstanding that key concept because that's not what I'm seeing in my code. Right, as we begin to hit the end of this, we can start talking about the message types at the end. And this is really about not making concrete classes to hold your data. If you think about it, we in C# we have an interface that says how it should look. Then we create a concrete class that implements that interface, and we then provide data into an instance of that class. Well, that's a lot of boilerplate code for just holding first name and surname or the order ID. And it also promotes bad practice where you can start to add methods that help delegate data, that help you configure information, go and get information from another source within that class. But at the end of the day, the information that we're passing around in MassTransit or in any queuing system or event-driven system should just be data. Really, that's all we should be passing across, whether that's binary encoded files or just first names and surnames, in this case like order ID and the date. You should be doing that within a anonymous type. Now this is called duck typing, where it looks like a duck, walks like a duck, and quacks like a duck. We have got an anonymous type that we're passing in, but it's going to be converted to submit order. Now, if any of these properties aren't in submit order, they're not going to find the way into the message, and they're not going to find the way then into the consumer. But this is a very powerful and clean and easy way to actually submit your data, whether you're using send or publish to get that anonymous data type or that type into a queue. And like I say, it doesn't error if you put data in there that's not in the interface. It simply doesn't go into the queue. That can be beneficial when you're trying to A/B test or roll out new features. You're not ready to roll out the interface yet, but you're going to. You can deploy that interface to your deployment engine. That will build, release, and then all of a sudden that new property will become available within your messages. Really, really easy and clean. Here they're using a date time UTC now. I highly recommend you don't do that. There are ways of actually using time now, GUIDs and IDs, which have scope. If you consider that you want to submit an order, send a testimonial, send the dispatch, do 20 different things, you're going to end up with 20 different dates, even if it's just a few milliseconds out. So you really should have something that's concrete with the scope of that request. Now, anonymous types, they're just interfaces, and you can have your data types as usual. So when you send them, here we go, we can use things like new ID to generate a GUID, or in my case, I use the invar, and invar, I believe, allows you to get IDs and timestamps. So I prefer using that. And that data then just gets submitted across. But there are cases where you've got data, but it's the configuration options, or they're not particularly related to that order, but you still need that data to be sent across. An example of that is things like conversation ID, correlation IDs, span IDs, and any kind of debugging metrics that you need. Well, you can do that by using a header, and you can provide this underscore underscore, and that will then find its way into the message as a header. So with headers, what we're able to do is provide a underscore context, bit of magic sugar that allows us to decorate our message with information, but we can choose which subsection that data should go into. So for instance, here we're going to show header, and I'll explain that in a second. And then there's some variables. Zipkin is another tracing tool, very similar to Datadog, that allows you to look at how information's flowing through your subsystems or microservices. So let's have a look at the code. Just updated to include some underscore underscore header, my value, header, my custom data. So that's the value I'm going to insert, and that's just obviously a hello world. And I've submitted that off to the queue. And if I have a look at the queue now, we can see there is these subsections. Now headers are normally blank. It's an I think it's an empty object. Yeah. So it's just an empty object. But what we're able to do is provide custom headers. So value, well, we entered two, right? That was the value we put in, and custom data was hello world. If that includes things like the Zipkin ID or the Datadog span ID, that'll allow you to configure that within logs and to be able to grab link data together, as well as like a correlation conversation ID as well. They're useful. So if you ever need to provide unique data, especially data that's not in your interface, then you can provide it as a header. But be warned, don't be lazy. Don't start going, oh, my development team's taking ages approving a PR for the interface update, the mourning over the naming convention of this property. So I'm just going to hack it and put it in the headers for now. Please don't do that. Please make sure that you don't uh, abuse the headers and use it to pass data in that the team hasn't agreed upon as a message contract. That's a way of being able to make sure your system fails quickly or fails badly. So let's go down further. And we talk about variables, and this might feel a little bit obvious, but obviously you can put variables as your types. But really, if you think about what's going on here, we are duck typing a new anonymous type, casting it to an implementation of that, and getting values in from other sources as variables. Well, there's quite a lot going on there, especially if you want to then call methods. So, for instance, let's say you want to get your customer, but the customer needs to be taken from another location, or you want to run a method or even generate a function that returns a customer. Well, with this, you've got to be careful because this isn't working the same way you'd expect your standard code to work because this is using this special anonymous type. So if you weren't careful and if MassTransit weren't careful, this would run after it had constructed this object and maybe after it had even sent it. But the way that MassTransit implements this is it does it one by one and it does a good job of making sure that it's done. You can also put async on the front and MassTransit will try and honor that. But it says, your mileage may vary, however, if you try and do that. And it kind of makes sense because if they're going to iterate over these lists, then the only way to really get it to the top would be by working out how it's iterating and making it the first one and then asyncing that. But way too complicated. You don't need to do that. If you do, then async your stuff just at the top before you publish. You know, as you call this, make sure that you've set up all your variables, and then once they've all completed asynchronously, then you can run the publish. Just an easier way. We've already talked about headers. So what are we doing here? Okay, right. When we look at a message, there is lots of things in here, the host, the configuration, source, conversation ID, but there is also hidden ones or ones that you can provide and that you can override. So here we're overriding the fault address. So if there's a particular exception thrown, if the consumer throws an exception, instead of going to underscore fault, so if we looked at my queues, sorry, my touch screen's a little bit sensitive, we would have a submit order underscore fault if this threw an exception, and the message would go in here. Well, you can configure that, and you can say that I want to change the fault address. I personally wouldn't, because this is within an individual sending a fault address just for one particular type, and I don't think that's something that you should do. But mass transit being mass transit, there's a convention and overrides that you could do to the bus, which allows you to change that as well. So everything is configurable. So we've hit the end of producers. Woohoo! The next one we're going to start looking at is exceptions. So I hope you like this video as usual. Thumbs up, subscribe, notifications, bells, all that stuff. It helps out with the channel. And thank you for watching.